Hi, thanks for joining me. Here's an interesting number theory problem. Some sets of prime numbers, such as 7, 83, 421, and 659, use each of the 9 non-zero digits exactly once. What is the smallest possible sum such a set of primes can have? So we're looking for sets of prime numbers, and within that set we use each of the digits 1 through 9 precisely once each, and we want to find the set which has the smallest sum. If you want to have a go at this problem, pause the video now and give it a go for yourself, and I'm going to dive straight into a solution. Okay, so we'll start off by just writing down all the digits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, if I haven't made a mistake. Now, what we notice is that prime numbers can't end in a 4, 6, or an 8. So if we have numbers in our set, they cannot end in a 4, 6, or 8 because they're all divisible by 2, and none of them are 2 exactly. So to use 8, 4, and 6, they have to be in at least the tens digit of any numbers within our set. So we need to have at least 40 something, 60 something, 80 something, but perhaps those won't do and we'll need to think of bigger numbers. So maybe 800 and something, or 600 and something, and so on. But it turns out, in fact, we can just keep 4, 6, and 8 in the tens place of numbers. So if we look at 40 something, 60 something, and 80 something, so we're going to put numbers in there. And so those are those numbers kind of dealt with, semi-dealt with. And now we think about 2, 3, 5, and 7. Those by themselves are prime, and in fact 2 and 5, they're going to have to be by themselves as primes in our set. We can't have them in the units digit because otherwise we won't have a prime anymore, because any number ending in a 5 that isn't 5 isn't prime, and similarly so for 2. So these ones we're going to keep as singletons in our set. So 2 goes there, 5 goes there as a singleton. And now we're kind of left with 1, 3, 7, and 9. And now 9, we notice, isn't prime, so we can't have it as a singleton. So we'll probably try and shove it on the end of one of these numbers here. So 49, unfortunately that's not prime, it's divisible by 7. 69, that's divisible by 3. 89, though, is prime, so I can put the 9 there, thankfully. So that deals with a 9. And I've still got 1, 3, and 7 to deal with. Now, I have to put 2 numbers in here, at least, for this to work. And notice that it doesn't actually matter how I put these numbers in. It's not going to affect this sum, because this is going to be 40 plus one of these 3 digits. This is going to be 60 plus one of these 3 digits, and the remaining one will leave as a singleton. Now, firstly, this 1 we can't leave as a singleton because 1 isn't prime, but thankfully both 41 and 61, they're both prime, so I can put 1 in either one of those spots, that's fine. And then I just need to put 3 and 7 somewhere. So I noticed that I could do 43 and 61. That works perfectly fine, and then I leave 7 here as a singleton. And this works for my set. So my set is 43, 61, 89, 2, 5, and 7, and if I add them up, the sum is going to be 207, and therefore this is our final answer. This is the smallest possible sum that such a set of primes can have. And of course this set isn't necessarily unique. I could swap, for example, the 3 and the 7 here, and this wouldn't change the result because 47 is still prime, and 3 is obviously prime. So there is multiple ways to get to a set, but the sum remains constant, 207. Anyway, I hope you have enjoyed this quick number theory video. If you are new to the channel, please do consider subscribing, and also if you've enjoyed this video, please do give it a like as well. Comment down below if you want to see any other interesting number theory problems, or if you thought of another way of going about solving this problem. Anyway, thank you for watching. I'll catch you in the next one. Have a great day.